Welcome back to a little series where we are making a mini Rust in Rust. This is video 7. We are going to try and do some evaluation this time. So we're going to actually have a program that runs, that does something. Well, maybe not a program. We're trying to we're going to do a calculation. We're going to evaluate an expression. So I've done a little bit of fiddling around offline. So I just moved the Lexa module that I had in this main.rs into its own file, and I moved the parser that we started working on into its own file. So we just got the main in main. So let's just talk a little bit about what an interpreter is, and some of this overlaps with what a compiler is as well. So far, everything we've done overlaps with how compilers quite often work. So you lex things to get tokens, and tokens are basically things like numbers, brackets, plus signs like we've done, keywords, stuff like that. So then you just have a flat list of tokens, just saying, I've broken this up into the bits. And then you have a parser which reassembles those bits into trees, which have, in some sense, have some meaning, or at least are the structure out of which you're going to get meaning. And so we've got a lexer and a parser. They do the most minimal possible lexing and parsing you could imagine, but they do it for the things that they work with. They work the same way that Rust works. And today we're going to write an evaluator, and that's where we differ from a compiler. And maybe one day we'll write a compiler for this mini Rust-like language, but I'd have to learn how to do that, so maybe not. But yeah, today we're going to try and start the first steps of an evaluator. And what an evaluator does, rather than a compiler which turns your syntax tree into machine code, what an evaluator does is calculates the answer to your syntax tree. So if we have, in our example, 3 plus 5 or whatever, the evaluator turns that into 8, right? It actually calculates the answer. So an interpreter reads the code and understands it, which we've started on, and then it evaluates it and turns it into an answer. So what that means for us is that we've already lexed it and collected it into a list of tokens. So now we can say we also want to parse it. So we want to parse the tokens, which I guess we do with tokens.iter, or the tokens question mark, because if it's an error we want to bail out. And it's going to give us a vec of syntax tree. And we're using the same trick where collect turns the result into, instead of it being an iterator of result of syntax tree, it's a result of vec of syntax tree. This collect is clever enough to do that. And we want into iter, because that was giving us references to tokens. We want actual tokens that we own. And now we're going to call eval on our list of syntax trees, or rather our iterator of syntax trees. And this is going to give us back a value, and we're going to print the value. So this is what we're going to try and implement today. We're try and get the most basic example of that working. Yeah. And yeah, at some point we might also want to look at proving to you that this can actually be instead of it needing these vectors here, it can actually just be a continuous stream of turn these tokens into syntax trees and then turn these syntax trees into values. Yeah, because at the moment I've designed it that way and then I haven't actually used it, and maybe that seems a bit wrong. All right, so we need to make an eval function. We'll put it in our evaluator module. Evaluator eval, and I guess we're probably going to be returning some kind of value, I guess. So we'll assume, like, we've got a similar pattern for our lexer, our parser, and our evaluator. So yeah, I think hopefully a lot of things are going to feel very familiar. So we're going to have that eval function. Like so. We said it was going to return, well, I guess it's going to return values, which is going to be a thing we're going to provide. Should it? Well, hang on. What did we call? We called the lexer returns a lex, whoops, and parser returns a parse. So I guess maybe an evaluator should return an eval, but I think it's the best name for it is values. Like it's an iterator over, like it's these names that are wrong. These shouldn't be called lex. They should be called like tokens, maybe, or I don't know. Oh, I don't know because. Right, let's not agonize. Let's just call it values for now, and we'll see how we get on. And that values is going to be a struct. I guess it's going to be a pub struct, so we can use it. And this is going to be a pub function, and it's going to take in. It's going to take in a stream of syntax trees or an iterator of syntax trees. So let's call that trees, and it's going to be. Let's call it I again, because it's an iterator, and I is going to be an iterator where the item is a syntax tree, like so, and that should be values, and we're going to, so again, we're going to do just the basic thing of we're just going to return a values, which this should be trees, which holds on to trees, like this. So I guess values is going to take that same type of I type thing. And again, it's going to be the same where clause, like so. And so far so good, but when we actually use that in main, it doesn't yet implement. Oh yeah, there's no value yet. We're gonna. I'm not liking the fact that values and values sound so similar, but we'll get there. Whoops. So, all right. Oh, maybe didn't need to import value anyway, right? Let's see. Okay, so yeah, values is not an iterator. Is our main problem right now. So let's make values an iterator. Oh, hold on. This should be an iterator over the items are values. No. Wrong. That's the this is what just saying what I is, which is what values owns, which is indeed an iterator of syntax trees. But we're going to import iterator for values, and it's going to provide items which are of type value, like so. So if we just return none for now, well, that should have its generics, which means we need to provide them, which means they need to comply with this where clause. Okay, so now we've got the basic structure of we can iterate and we'll get back a value each time. And values are not. Oh no, it should result. Yeah, it should be giving us back. No, I've done this. No, it is right. It should be giving us back a result of value, right? Because evaluation can also potentially go wrong. And it should be a met result. So the main method should be reasonably happy, but value doesn't implement debug, so we can certainly derive debug for it. And that hopefully is the approximate structure. And we still don't need to import value, I guess, because we're not actually putting them into a vec here, so fine. All right, so that's what it's going to look like. Now we need some tests for our evaluator, right? So put the test in config test and write ourselves a test. And what's the dumbest test? It's like when there's nothing, you get nothing. Evaluating no trees gives no results. I always like to have a null test because it lets me get my types right. So we're almost certainly going to have like we had before, a function that evaluates a vector, eval v, takes in what, returns what. So it returns a vec of value, and it takes in a str, I guess. That's what we want to test, basically. Like when you have this program, what's the answer? We'll just bring in everything from super just to fit my pattern. Okay, and then this is going to be, all right, it's going to be the same as what we've done in main, basically. Something like lex them, and that'll be just input, and then parse them, but question marks no good for us. So instead we're going to do expect. This is lexing error. I think that's how I put it in the other bit. And this will also be an expect parsing error. And this we're going to do, actually we're not looping through it. We're going to say let values, which is we're going to do exactly the same as the other. Get result of vec of value equal this type of stuff. And then we're going to return that like so. Okay, something's wrong because it's not formatting my code for me. Well, I've got curly bracket problems. I've forgotten a curly bracket. Is it as simple as that? Yeah, okay. Yep. So definitely need a token, and we need to be able to lex. So this is a potential philosophy clash here. So what I am doing is I am testing evaluator by lexing and parsing and evaluating. So you could definitely say my tests are covering too much stuff, but I tend towards what is called the classical TDD approach, where you tend to do stuff more like that. Whereas what's used to be called the London School would say you should only test the exact thing you're testing. I'm really driven by clarity of tests. And so I think this test is going to be so much easier to understand. If I just say, when I evaluate the empty string, I get back an empty list, right? Something like that, with probably a bit more stuff. That is so much easier for me to understand and therefore write good tests than having to construct a syntax tree and pass that to the evaluator, and then somehow have sensible thoughts about what that would evaluate to. So there may well be specific tests where we do want to do something like that, but I don't think it really costs me much to structure my test in this way, because I've got my lexing and parsing tests, which I can give the exact same examples to, and I know that they lex and parse correctly. So all I'm actually testing is that all I'm actually testing here is that the evaluator works, but I can have much easier to read examples. So, that's my argument. All right, now what's the problem here? It's saying, what's it saying? That values doesn't have the right type. Yeah, we need to somehow expect on that to say evaluation error. But there's still something wrong here. Let's build here to get a better idea of it. So we expected a result of vec of value, but we found a values into iter. Oh, I'm not collecting. Yeah, that would be why. Because it's collect that does the magic. Why am I into itering? Oh yeah, no, I've got collect in the wrong place. I should be collecting the return value from eval. There we go. Okay, so now I've got my eval v. If I run that, I think it will pass. Oh, I've got a warning. Trees is never read. Okay, I don't mind. We'll get there. Okay, if I run that... Now, I'm frequently getting this flake where somehow setting up miet is causing error, and if I just run it again, it works. So I'm using miet wrong, I think, in the test where I check for error cases. So we might need to revisit that. But yeah, for now we can ignore it because it goes away when you run the test again. Okay, so that test passed. Let me just double check that it ran. Yeah, evaluating no trees gives no results. So let's make a test that's going to fail because it's not very satisfying at the moment, is it? So what if we just evaluate the number 3? Then we should get back an answer, which is well, I guess it's an I32 because that is the default Rust type if you don't say what number type it is, and it's an integer. I'm pretty sure. So I think it's going to be a value of type I32. Which I guess we're going to spell like that, and the value of that value is going to be 3. I kind of hate that, but there we go. So, all right, so that means value is an enum, not a struct. Fine. And it has a thing in it called an I32, which it holds an I32, right? Yeah. And this should now be called evaluating an integer gives the correct I32. Something like that. Test it. It's going to fail because we got back nothing and we should have got back an I32. So I'm feeling the need to start checking things in Rust. Like maybe, write some little temporary Rust programs and figure out what happens. I mean, the simplest thing we can do is just make the number 3 here and then ask our editor. And its type is I32. So we are right with that guess. But what I'd really like to do is be able to pass some code, either like actually run externally the Rust compiler, or maybe there's a way of running some bits of the Rust parsing and lexing and parsing framework so that we can check it against our own lexer and parse and see if we get the same results. So that's something I'm interested in doing soon, let's say. By the way, let's just make this number a bit more interesting. Just to double check it's all working out fine. Okay, so, okay, we are almost at the point, we're at the point where we need to do some evaluation. So in order for this to work, we need to do the same kind of thing that we've done before, which is if let sum. I almost feel like I should be, I mean, the other option I have is, this would be better. If I do self.input.next, that gives me back an option of a syntax tree, right? Because, I've called this trees. In other places I've called it input. Should we call it input? Then it'd be really regular between the different files. Let's do that, see how it feels. So self.input.next is an option of a syntax tree. And if I just question mark it, that means if that's none, then immediately return. Because that's what question mark means on an option. If that's none, immediately return none, is what I'm getting at. And that means I can really make my code a lot nicer looking without that if let that I had in the other places. So we'll definitely make that same refactor on the other bits of code in a second. But let's start out by saying there's two possible syntax trees that we currently understand. There's a leaf and an operation. We're going to leave operation as a to-do. That's not how you do that. I guess what we can... No, let's just leave it out. Just leave the warnings in for now. So syntax tree leaf contains a token. And there's actually different types of token that we might want to match on. So we can actually say token, and if we import that, it'll help us, right? Token int or token operator. Now, if it's token int, then inside there is a string. So we can say literal is what we called it in other places. And if it's an operator, I guess we don't care. So if it's an operator, we need to think about like how are we supposed to evaluate? If we just got like a plus symbol, how do we evaluate that? What does it mean? And I guess the point is it's not a valid leaf. So maybe leaf shouldn't hold on to a token, but something else. So we should think about that. But in the case of an int literal, then the answer is pretty straightforward. It's just a value of type. Well, it's not. Eventually, it's going to be much more complicated than this. We won't be able to actually figure out the type of our thing until we've figured out what type we've asked it to be, because Rust is really clever like that. But for now, it's just i32 parse. Is that how you do it? From... No. Is it... Maybe we'll do a try into on literal. Dot try into. Like that. And then for one moment, let's just crash on error. Unable to parse i32. Something like that. And we should be wrapping this in a sum because we haven't reached the end. Maybe some other thing is going to get wrapped in a sum eventually, but like the whole lot maybe. All right, so what have we got? Oh, we should be returning a result. So there should be some OK. And I guess that gives us a clue about what we should do about when try into fails. Okay, you can't make an I32 from a string. So how do you parse? Let's look this up. How do you parse? So let's use one of the cool features of this, which is we can say string to I32 or str to I32 maybe. Yeah, I32 from str is what we were looking for. So yeah, you just give the function signature in this documentation and it tells you the functions that fit with that. Isn't that nice? So I32 from str is what we're looking for. So how many brackets have I ended up with? Too many. Some OK value, and this should be I32 from str. Why is it offering me from str radix instead of from str? I mean, that's fine. I don't mind giving a radix if I have to, but why is it not offering me the thing that I just saw we could have? So the radix is going to be 10. And a comma. And this is going to give us a result. So what we want to do is, instead of just okaying that, we want to map the error to say, when we got this parse error, what did it say? Yeah, what's it called? From str radix returns a parse int error. We want to turn it into our own error type, which is going to be, well, what's it going to be? What types did we have on the parser? We had some errors, didn't we? Things like unexpected token, unexpected end of file. So here we're unexpectedly unable to parse. We thought we ought to be able to. Oh no, that's not how that works. We thought we ought to be able to parse this thing because it looks like an integer. Now, obviously, there are going to be some failures, like very, very long integers and things like that. So I guess we'll go for invalid. Invalid number. Let's try that. Bring in what we need to make this compile. And the message here is going to be number literal could not be understood or something. That's really vague. We should definitely try and do better and see what Rust says for these different cases. So let's just to do that actually. To do better error description copy rust C. Right, so what are you complaining about? Yeah, we haven't actually returned an error yet, so let's copy where we do some returning of errors elsewhere, somewhere like this. And again, we're going to cheat and not actually fill in the... Oh, this is the place where we... that was the wrong one to copy, because that one actually, we did actually provide proper line and file and stuff, which we haven't worked out yet for this bit. So this is where we're going to look for copying the thing that just skips that, and instead of unexpected end of file, it's going to be, what did I say? Invalid number. And we'll soonish we'll make the we'll make this better. Okay, so value I32. Oh, hold on. Yeah, I can't do a map error here. That doesn't make any sense, does it? All right, well, I think what we should do is break this up. So let the parsed, I mean, parse is an overused word here. So let's use num equal this whole thing. And if it all goes wrong, then we'll just do a question mark there to say just return early if it goes wrong. And yeah, we need a reference to that literal. And if it didn't all go wrong, oh no, we can't. I guess we need to handle the error case and the not error case. I guess we can do a dot map on this to say in the good case we wrap it up in, so we've now got a number, right? So we wrap it up in this value I32 business, and either way we're going to wrap this whole thing in a sum, because we're always going to be, yeah, get rid of the let now, just go for that and say it's going to be some thing that may or may not be okay. And we've got the wrong result type here. The type constructed contains result value result, which seems wrong. Let's just get an error message on the command line, so I find it easier to get my head around. Yeah. So we need to just think carefully about what the types are here. So let's actually be really explicit about it, and let's say let num equal all of this stuff, and then semicolon at the end, and then the answer will be return that num wrapped up in a sum. But the type of num is result of value, comma, result of something, which is definitely not right. So that's because I need to do some kind of, well, let's break this up a little bit more. So first of all, we'll just do the parsing. And then, so now we know what type num is. Num has a type of result I32 parse int error. If it is, oh, okay, I've got it. So what we're doing is we're doing a map error to say, in the case where this is an error, transform the error into a different error, but we don't need to wrap this different error in an error brackets business, because it's what map error does is already takes in an error and you just give it a different error type to return. So do we like this broken up version? I think it's worse. Let's put it back to how it was. It helped us get to the answer though, so it was worth it. So let's wrap the whole thing in sum again. You might find this single line of code quite long. I must say I don't like it at all. I like all of this rubbish being in the middle of our flow of code feels really bad. Maybe we can do something about that. But yeah, I think we might now have got that test to pass. Got a bunch of warnings still. Yeah, look, our test passes. When we're evaluating an integer, yeah, we're not doing anything with that stuff yet. When we're evaluating an integer, like this, we get a single syntax tree, which is a leaf. And if it's a leaf with an int inside it, then we can evaluate it by just parsing that I32, dealing with some kind of error, and then returning it as a value : I32. So we're genuinely evaluating. So now we can send a number into our program, and it should evaluate and print out, yep, it's an I32 with value 45. And notice there's no quotes here, so it's an actual 45, not just a 45 as a string. We've got so many warnings, I'm getting really stressed out by them. Now, the thing that I really think is wrong here is that I don't think this should be a token that we're holding in the leaf, because the reason I think that is this case doesn't make sense. You can't have a leaf of a syntax tree that is just an operator. So in future, probably the next video or something, we will stop holding a token in a leaf and start doing something differently. Let's put ourselves a little to-do to remember that. To-do, clearly, leaf should not hold a token because the following is impossible. Hopefully that's enough to remind us of what we're doing. Okay, so let's try and get the evaluator to do something a little bit more interesting than reading a number in and then printing out that number. So evaluating an operation gives, or let's just say evaluating an addition gives the answer. I don't know how best to say it. So let's add up 89 and 11. The answer should be not 89 or 11 or anything like that, but 100. Now we'll really be, this will be a programming language if we can make this work, right? So first of all, let's check that our test fails. And it panics because we hit a to-do. Now, before we get anywhere else, let's get rid of some of these warnings because they're doing my head in. Like, these warnings are about to go, so that's fine. This one, we could ignore dead code warnings. Like, I don't understand why it's complaining about this. This is a public function, so it could be used by someone. But yeah, I don't know. I mean, if I delete it, my tests aren't going to work because it's used in my test. So I could make this test-only code. But I'm pretty sure we're using this in the parser, right? Did I misremember that? No, we're using it in the parser. Oh, but only in test code in the parser. Okay, so, I mean, I guess we can quieten this by just saying this is, not test code, config test. Like this. I don't like doing that, but I don't like scattering config tests all over the place. But, or anything that's like conditional compilation-ish. But yeah. Okay, the only warnings we've got left now are the ones we're about to fix. So if we want to evaluate this sum correctly, so if we run it at the moment, yeah, we hit the to-do. It basically, if someone has parsed our stuff and given us an operation, then it will have an operator, a left and a right. So in order to find the answer, we need to first evaluate the left and the right, and then apply the operation to it. So let's do that by saying, what is it? What's this called? Oh, right. Hang on. We need to break this out, don't we? Because we've written all this stuff right inside next. And that's going to come and bite us now. So let's break this out into... well, let's just copy this, shall we? An import block for values that is not an iterator. It's just implementing values. Doesn't like that. Okay, well, let's try with that for the moment. And there's going to be a function called, I guess it's called eval next if we want it to fit with the other ones, and it returns an option of result, get result of syntax tree. Yep. No, value. Getting confused with that all the time, aren't I? Yep, and that is just going to be all the stuff we have in here. In here. And next is just going to return that. And the reason I want that is because the iterator is kind of a detail, and the real interesting stuff is in here. But and now I need to break it out again because I want to eval a syntax tree which is not the next one in the input. So I actually want eval next to call another function which has a similar signature, which is going to be eval tree, let's say, because it takes in a syntax tree. Let's call it tree, shall we? Yeah, we'll think about that. And so this is going to call eval tree. And it's going to pass in this thing. Like this. Including the question mark. And here we just match on tree. So I think that works. And we've got some kind of error. Oh, I missed a curly bracket. That's the worst kind of error. Oh, there's two curly brackets here. Yeah, fine. Okay. What's your problem? What's your problem? Oh, we've got to get it out and then. So let tree equal. No, what happened then? Oh, I see. I tried to copy all the contents of a bracket when I was on a bracket, so it just copied nothing. So just to explain what happened there, it was moaning at me for calling eval tree and this bit all in the same line of code, because essentially eval tree takes a mutable reference to self, but also self.input.next. Next is a mutable takes mutable reference to input, which is part of self. So both bits of that line of code were both potentially mutating self at the same time. So we break them into separate lines. We don't have that problem. Now we're finally in a situation where we can start doing the work we need to do to calculate an operation. But I'm feeling really uncomfortable with how much code there is here. So I actually want to do something like make a I guess this is a leaf, so we can just say leaf, and that is gonna again return the same stuff. And it's going to take in a leaf, right? So well, at the moment it's not taking in anything, but we've got to make it take in this thing. So this is going to be, it's a syntax tree, but it's a specific type of syntax tree. So it's going to be whatever was inside that syntax, that leaf that we want, which for now is a token. So I guess it's going to be the contents of the leaf. So I'll call it leaf or value. Let's call it leaf for now. I don't know what to call that. I'm not happy with leaf. I'm not happy with token. And what that's going to do is all this stuff here. So, oh, in fact, yeah, okay. In fact, it's going to slightly change our structure here. We're going to match on, I think we're going to match on leaf like this. And then the two branches that we had as separate branches above are going to all be one. But let's just take this stuff first. And this is, if we match on leaf, and if it's an int, token int does this. otherwise, the case that we want to make now not exist anymore, but currently does. So this should just be leaf, and we're just going to call self.leaf with leaf. Hopefully that's okay. Then this case doesn't matter, isn't the right place anymore, because it should go here. And we're going to keep our comment saying clearly leaf shouldn't hold a token because this thing doesn't make sense. And here is where we should be using literal, providing literal. Okay, so that was just me breaking out leaf into a function. So now my eval tree thing doesn't look so bad. And we can do exactly the same thing here by calling a function called self.operation, which takes in an operator, a left, and a right. Now we need to create a function called operation, which takes in those things. Hang on. Should go there. So call it operation. It takes in our operator, which is a token. Again, it probably shouldn't be because not all tokens make sense as operators. Yeah, definitely. So that's definitely wrong too. Returns the same kind of stuff. And it also takes in a couple of syntax trees. Left is a syntax tree, and right is a syntax tree. And what we need to do is evaluate left and right to get ourselves a value, because currently we've got syntax trees and we need a value. So the way we're going to do that is to evaluate. The reason why I separated out this stuff is so now I can say evaluate the tree left, and I guess if that returns an error, we want to return an error, and if that returns none, it shouldn't return none. So I think eval tree shouldn't return none because we're giving it a tree. It's going to return a value. Yeah, that makes sense. So this should just return a result, not a option of results. And that means also leaf shouldn't return an option. And that means some of the weirdness that we were doing around like wrapping a sum around kind of everything can go away, I reckon. Maybe like that. If I put the bracket in the right place. That looks like it thinks it's okay. Let's have operation also not return an option. So all these things, we've been given the valid input. We're going to get a value back or a error, right? So now we can use question marks. So that's why this is nice. We can say left is either left is okay or we hit an error, in which case return it. Okay, now left and right are their boxes of syntax trees. So I guess we can just deref them and pass them in as a reference to a syntax tree, and then it'll be, oh no, if we just deref them it might work. We'll see. And now, yeah, now it needs to be an option. So I think once we've discovered that next is returning as something, so we haven't finished iterating yet, then everything else from then on is definitely going to be a value. So this sum is a suitable wrapper. There we go. Okay, now what is going on? Right, well, we haven't actually done anything here. So first of all, let's put in some kind of dummy return here, like a value. What types of value do we know? Currently only know an I32, so let's just return the number 2. So that should fail our test. Yep, because we expected it to be 100, but actually it was 2. I really hate that this has a capital I. I almost feel like we should... But then I don't think I want to name it the same as an actual Rust type. That would also be really dodgy. So I think we have to just put up with it. All right. So yeah, let's continue. So in order to evaluate an operation, we need to evaluate the left-hand side and the right-hand side, like so. And then we need to combine them. So based on the operator, which at the moment is a token, which is just so wrong. So clearly to do. Clearly operator should not be a token. We're going to match on operator and some of these tokens don't make sense. So the only type of token that makes sense is operator. That's really weird, isn't it? So we can just say does not make sense. So we'll leave it to do that. This could be just any kind of panic here. Well, no, let's make it a panic that explains why we think this shouldn't happen. The operator should be a token of type operator. So basically, this means that our parser went wrong if it got us to this place, I think. So that's why it's an error. We can get rid of this and say, right, if we have got an operator, the thing we got inside is the literal value of that operator. And we can match on that. And that is going to be, it's a string. So let's match on like reference to it so that we can try things like, if it's a plus, do this. Otherwise, do like some kind of error. Again, this should kind of never happen. I guess this is like unrecognized. Again, the parser's kind of created an operator that has a literal in it that isn't an operator. So what's it doing? Operator literal, let's say. So let's just have that parse enough for it to not all completely die. All right, so I guess instead of just reference to literal, if we say astra, we should be able to match against astra if we do that. Yeah, that is good. So here, this is somehow we have an operator with that is made from a string we don't recognize. Like I don't know how to write this. String we don't recognize. So I'm feeling like there's a huge amount of refactoring we need to do to make this stuff make sense. But hey, that's TDD, right? All right, so this is the good case. When we got a plus operator, everything's going to be okay. We're going to add up the two values that we've evaluated and get an answer. But hold on, these values could be anything. They're just values. So actually, we need to match on not just the operator, but also, I mean, we could do it for now, we could do it inside here. We can say match on, like, let's say left and right. And comma at the end. And can you fill that in for me? Yeah, okay. So that actually at the moment we only know about i32 values, so this is all good. But soon, like we're going to like not be able to add an I32 to a string or something like that, right? So then it's going to get, oops, that should be right, obviously. Now, the answer to adding an I32 to an I32 is an I32. Like this. And the specific I32 that it is left plus right. And I guess it should be okay of left plus right. Now, what do we want to do about overflow? So what we're doing at the moment is exactly replicating the behavior of Rust, which is that, like, we're adding two I32s here in Rust in order to get an I32 answer in our language. We might, at some point, want our language to be more cautious than the default behavior of Rust and, like, throw on an overflow or something, or not throw, fail in some way when it overflows or something like that. But I think for the moment we want to follow the exact rules. So they've done just blah plus blah. They haven't done some special tell me about overflow operator. So there's the return type of this plus in our language is going to be the same as it is in Rust, which is an I32, not like say a result of I32 or something like that. So we haven't left ourselves many options to do anything other than exactly what Rust does. So let's see whether it passes our test. It does. So let's try it out. Like so. And look, it works. We got out the answer to our sum. So we have written Alexa, a parser, and an evaluator that can do a useful job. Like in principle, if we needed something to add numbers, we've written a program that can add numbers. And its program is called milk. And we can do, 1 plus 5. Oh, does that work? No. So at the moment, 1 space plus space 5 does work and gives us 6. By the way, it gives us 6 in this not very nice to read output format. So we might also want to, let's put another to do in, shall we? Given it seems like we're using to-dos to handle our to-do list for now. So to do nicer output format. And then somewhere we need some to-dos that say to do standard way of comparing Rust with milk. Am I spelling milk with a capital M when it's in this context? I guess I am. All right. We've done it. We've got an evaluator that can add up numbers. Well done us. Let's give ourselves a pat on the back and see you next time.